Okay. So we already have a stock setup and we already got a stock model. So like I said, when you want to see it, you can just click on that or hold the Alt key. It's the same thing. So the first clip what we're going to do, this is our 3D plot here, guys. I want to figure out if this is something you can try to I want to try a two part. This is a finished radial. I want to try a rough radial first. And some of the things that you don't see here in your recognize. What you do, you right click in the white area, and you go mill two part, go to surface rough, and if you see there is your radial rough two part over here. We have finished radial over here also, which we saw finished radial is over here, right there. Now rough and radial, we don't see it here. When you right click here and you go into mill toolpath, that's when you see all the toolpaths for rough and for finish. Then you have 3D high speed toolpath, waterline, scala, raster, pencil. We're going to talk about all of those. But you're going to see most of the rough here and finish. You're going to see then go to surface rough again. Right click in the white area, not in the black area. Right there. Mill toolpath, surface rough, then you do radial. Now I say you want to do boss, or you want to do arrow. So this is kind of our boss. This is our boss. The radial toolpath is good for a circular part. You can try this. Let's take an example of a round wheel. So your circular wheel is going to be has a radius. The toolpath is going to go from outside to the center, and you will follow the radius. That's why the name is radial toolpath. And you can see the motion of the toolpath. It's going to start from the boundary. It's going to end up going to the center. And it's going to cover all this radius. That's called the radial toolpath. So for circular part, always try to use this radial toolpath. We'll be trying different toolpaths. We're going to start with radial, then you can also rough it up with 3D high speed area roughing also. So this is boss. We can go in boss because this is a boss. If you have a cavity, then you can select as a cavity. When we're talking about cavity, we're talking about a pocket. That's your cavity. This is your boss. You can select boss. But when you say undefined, it's still. Okay, so I'll know that this is my boss, I'm going to select the boss, and okay, and it's like solid phase surface, like I always do that. Select all the surface and selection. We have 1, 2, 3, 4 surfaces. There we go, it says right surface, 4 selects the surface and good. Select it. We'll show you how to select the four surfaces. That's good. And okay. The tool for rough. We use all 3D surfaces, guys, no matter what. We use ball and mill to finish it. So the way we do rough pass, and then we do semi-finish, and then we do finish. Or you can just go rough and then go to finish. You can do that also. Now with the rough pass, for roughing tool, you're going to use always your bull nose. It has a radius, corner radius, and flat on the surface. It's called your bull nose end. radius could be 1/16, the radius could be 1/32, could be any radius, the radius could be even 1/8. The ball on the quarter radius of this. And this is going to be here your flat. So that's your bull nose. So that you can use this for your rough pass, you can also use this for semi-finish also. Then for your finish is your ball end, always. Just like a ball. And it's supposed to be circular. Like this. Circular. That's your ball end. When you're talking about ball end mill, the ball end mill is going to machine your surface and every corner is going to touch your part. That's your ball end mill does. Doesn't matter which side it's going to cut. It always cut with the tool is going to be always intact with the part. So here, if you want to finish this part, we can rough it out with a flat end mill. We can take as much as material we want. Then we can get a bull nose, get it close semi-finish. Then with ball end mill, yes, the ball end mill. Look at this. If your ball end mill is going to cut this, it's going to come up. It's going to cut with the center. Then it's going to cut with the side. It's going to keep going up. It's going to cut with the side. And then when it's going to go here, it's going to cut with the bottom. So every time it's going to be, it's always cutting 90 degree as a radial on the part. When it's going to be touch with the part. So if my part is like this, something like this, my part, and there is my surface right there. So look at this, how your ball angle is going to cut. Then it's going to come over here, it's going to cut with this area, and then it's going to go over here, it's going to cut with this area, and when it's going to cut to the other side, it's going to start cut with this area. So here, the step over for finish, guys, we use anywhere from 5,000 up to 12,000, depends on your finishing part. So this is my step over. 5,000 is really fine finish. So we're going to stay with about anywhere from 8,000 to 12,000 for our step over. That's how much it's going to cut each step with the ball end. That's for your finish. So keep that in mind. You're going to use bull nose for your rough, and you can use ball and mill for your finish. So here,
Sir, would you use the same step over for the bull nose as well, like 8 to 12,000?
what happened? No, you can go even more. You can go 100,000 on that.
Okay.
Oh yes. No. Bull nose, we're going to take one chunk of the field. We don't use, we can use flat end mill, but flat end mill does not give you a really a shape of your part.
Yeah.
But you can take a whole bunch of material, then you can get bull nose. Bull nose will give you it's going to create the shape of your part very good. So I'm going to use here is my flat, here is my sphere end mill, sphere or ball end mill, same thing. And this here is my bull end mill. I'm going to select bull end mill, and then I'm going to select half an inch bull end mill. Let's say my side equals 2.5. And I can pick all of them. And now you can pick the bull nose radius. I can pick 62,000 with the bull nose radius, or I can pick 31. Let's pick this one. This is what we have in the shop. We're going to use that one. So the 31,000 radius bull nose. Corner radius. Okay? Speeds and feet. My part we're going to cut at surface feet, I can easily go 730 speed, surface feet per minute. Speed comes at 5348, feet rate 42. This is a good speed of feet too if you want to cut the aluminum. The stuff we're going to cut, guys, is like a butter. I'm going to just bump up my spindle speed about 6,500. And look at this, my cutting speed went to 850 and this is 42. I can go at least 65, 70 inches per minute on that too. Plunge rate, I can go about 25 to 30 on my plunge rate. And retract rate, I can go 100% on retract. Okay, surface parameters. We can always cut with the tip. Start to leave. This is my rough pass. I'm going to leave about 30,000 for finish. Start to leave on the check surface, we will talk later on about check surface. We are not selecting any check surface, we are only selecting the side surface, so we will look at that. Retract 250, that's pretty standard, shoot 100,000 is okay in incremental. Tool containment compensate is going to be the center of the curve. Inside is going to stay inside of the curve to the inside, and this is going to come to the outside, so it's going to stay to the side. Rough radial parameters, there we go. The total tolerance is pretty standard, guys, 1,000. Cutting method, we can go one way, and we're going to start from cutting from outside, and we're going to cut from both sides. Both sides means going up and coming back is going to go back from both sides. Maximum angle increment, I'm going to change that, and we're going to see the difference. I'm going to change to 20 degrees, and offset distance, I'm going to change it to 150. And we're going to come back and we're going to change those numbers. Cut depth in incremental, you don't have to worry about that. You already know the depth when you set the surface, that what's going to be the top and what's going to be the bottom of it. So we don't need to do that. If you're really concerned about that, you're going to say, I'm going to start at 0, and what's going to be my maximum depth? It's already picked up right there, your maximum depth. You right click there, you say select on Z, so your maximum depth, you're going to go up to here, and it will still comes out -1. But we're going to stay in incremental. Incremental means from here, it's going to go up to this, 10,000, that's the minimum, but we're going to go more than that. Maximum step down is 100,000, so it's going to go 100,000 each pass. It's going to go 100,000 each pass. That okay? Select the radial point. The center point of the rod is your radial point, which is going to be this guy right here, the center of that. Is that okay? There is your tool path. Now, if you look at that tool path, you're going to see back plot, it's going to cut like this. But let's look under our verify. So why you see this material uncut, guys? This is controlled by the angle. The angle we have changed, that's by the angle. Look at that. So here, if you go back to parameter, remember that angle I changed to 20 degrees?
Yeah.
Let's try to go to 10 degrees. The angle between each pass, look at this, that's 10 degrees, that's what it is. It's going to be a little better. It's not cutting here. It's not cutting on the first pass. You see that, guys?
Yeah.
So, what you do, you go under cut depth, and we say in incremental adjustment to the top cut, I want to cut 100,000 on the top cut. I want to go deeper. So do you see that there's any, it still has a little bit of material here, but look at that is your angle. Now what you see here, your two, and I'm going to bring my stock a little bit, and the stock side. About 50,000 out. Bring it up a little bit. You see that? In the front view, so you look out Z over here, 50,000. that, guys?
Yeah.
So if we will verify this again, all you're gonna see is Kelly right there. This is, if you look at here, with the center, it's leaving a little uncut material here, right guys? Yeah. Look at that, right there. Really slow on that. That tool goes barely to 250, so what was that? I'm not sure. Start offset 250. So what's happening is your center of the part is right here. So your tool is cutting from here, is going, but is offsetting from the center 250, meaning the radius of the tool is 250, so it's barely touching the center. I want an offset less than the radius of the tool. The tool radius is 250, I'll go 200. Then if you go 200, then this tool is going to come, it's going to pass the center. Every time it's going to come, it's going to cut, and it won't leave any material here. That's what it is. The offset has to be less than the radius of the cut. So let's make that 200 or even 150, that's fine. 175. Let's start offset distance from the center. The radius is 250, now it's going to stay 175. Look at that, it's going to pass your center line. See that, guys?
Yeah.
So this step over is a little bit too much. I'm gonna narrow down my angle. Look at that. Look at that. So what I'm gonna do, let's try. My angle, I'm gonna go about 7 degrees. If you are cutting aluminum, we are still if you're cutting some stainless or hard material, your angle, you can even narrow down your angle to 3 degrees. Let's go about 5 degrees. Look at that, can you see that, guys? This one here, that's where it changes your, it starts, look at it, it starts from here, the first pass, then it goes around and it goes out here. That's why you see that irregular step on all the four sides. That's all. Let me see if I can fix that. Around negative Z motion, around positive motion. sections over here, right? Again, it's not bad. Okay. So now we're gonna go ahead and see and save that part. And we have 30,000 material left over here for our finish. So that is how my part looks like after first operation. So what I'm going to do, I'm going to create another stock model. I'm going to click on stock model. And this time I'm going to name that you can say stock rough class. So we got this. The first stock model we had was from the stock setup. This one we have is from that stock we created. So this time we're going to say we want to create stock rough pass on a stock model, and that stock model was our real stock. The source operation is going to be this tool path, the one we just created. So what we are trying to create, we are trying to create that how my stock is going to look after I do my rough tool path, which has been cut on this stock. That's what that means. So when you go stock definition, you're creating a new stock model that has been cut out of the real stock, the one we created. And the tool path is going to be, and the source operation is going to be by this source. That's what it is. And you hit OK. Create a new stock model like this. There is my new stock model. When you select all, you turn those all off. And you create just on this stock model, you will see that how that part looks like after being cut with this tool path using this stock model. That's what that is. Click on that, and there is your first one. This is your real stock right there. Look it up, look at it, that's your real. Turn that off. That's your this guy right here. After this tool path. That makes sense, guys? Yeah. So each time you're going to go create your stock model first, create a tool path, and create a stock model. You see what you have done with this tool path out of this stock model. For each tool path. Now we're going to do the final, so we're going to see what we got final from the first row. then we're going to create a tool path, create another stop. Then we're going to create the last tool path, which is going to be leftover or pencil. Then we're going to create that start model from the first step. Okay. So minimize that, minimize that, minimize that. Let's talk about our finish tool path. We're going to go 3D high-speed scallop. Just to maintain equal scallop, this equal height is going to cut toward the surface. So that tool path is going to be under finish. Select your scallop. Or you right click here, go to new tool path, go to finish, and there is your scallop. I'll go ahead. Make sure you close that just by clicking this. It's just like a tool path. The operation selected, select all the operation. Come out. There you go, that's what you need. Okay, scallop tool path. Okay, the scallop tool path, we have start left 50,000, 50,000, double click it, make it 0. I do not want to leave anything on the wall. I do not want to leave anything on the stop, on the floor. Select entities, just like we always do that, select all entities. And have a selection. Go to 4, surface selector. Tool path control here, we're going to give it containment boundary. The tool is going to stand on that containment boundary. So go and select that containment boundary, which is going to be this guy. Okay. Strategy close offsets, that's good. Tool containment, apply. Compensate is the center, or you want to go inside the tool, inside the boundary, or you want to say outside the edge of the boundary. So most of the time we just take the center of the curve on the boundary. Tool, we're going to use a ball ender. Select collaboration tool, filter, say none, and there is my ball or sphere, same thing. Also creates this one. Creates ball. You'll see only one. Creates ball element. Okay, what we will cut parameters. Cut style, we can go one way. Emphasis is put the tip. Step over. Let's go about 12 powers step over. You have to step over the scallop height is going to maintain because it's 0.000006. This really is going to be really good. Steep and shallow, you don't need to worry about that. This is angle from 0 to 90 degrees. Angle just like that. Anything falls in that is going to touch it. So we are good at that. Linking parameters. Retract to 2 inches, guys. I'll leave this. The default numbers are good. Keep the tool down within percentage, 100% of the tool. Linearity exit 25,000. That's good. So this is good. You retract, you read it. These are the default numbers. That's it. Pretty much of this. Planes we have to do the top on this. Arc and frequent tolerance, I'm going to come back and talk about that. Let's go to tool. Okay, the tool we are using 3/8 ball and mill. And it's gonna leave a 3/8 radius over here. It's gonna leave a 3/6 radius over here. Going 1.875. So which is okay. You can see that there's stuff over here. So that looks pretty good. So I'm gonna go ahead. I'm gonna go ahead and create a stock model now again. And name the stock model against the stock finish. So now this stock model is created, stock finish is created from stock model, no, it's created from stock rough. Created from stock rough, which is this guy right over here. And the operation we're using is using 3D high speed scalpel. Okay. Look at that. The finished tool path you see and you finish surface you see how close they are. They're just bleeding into each other. You see that guys?
Yeah.
But this is a really good tool path because you see the original surface. That make sense?
Yes.
You see the original surface. But here, you see our tool radius was 3/8, right?
Yeah.
We have a 3/16 radius over here, 0.1875. That's why it's solid gray over here. If you look at the bottom here, that's where you see the stuff. All down the stuff. We are zooming it in, that's why you see it. Here, it's blending into your surface. That's pretty good. Now, look at the 3D high-speed scala that we did. Go back to all that. And go to information. It takes 2 minutes 46 seconds from that. Now the tool path files, if you see that 4057 kilobytes. Right guys? 4057. So, if alpha to parameters, I go to cut parameters. Under arc filter and tolerances, I'm going to say check line and arc filtering and smooth settings. Cut tolerance will go right in the middle in those. Cut tolerance and line and arc tolerances. You can stay cut tolerance maybe 30%. Line and arc about 35 right there. And same thing with the smooth moving side. So if you check these two arcs and you say I want to cut it G17, G18, or G19 plane, and hit OK. Look at my size of my toolbox. From 4,000 to 1,600. When you run that part, you will not see the difference. You cannot tell during the tool path that there's going to be any changes, because what it happens, the tool is going to figure out when it's supposed to G17, G8 square. If it has to do a create an arc, it will do an arc, or it has to go into a straight line, so it will figure out that sum. And there's going to be less step on that tool path, and that's why the size on the tool path is, because it's from 4,000
So instead of like a million different linear movements, it's more G2s, G3s.
Exactly.
Yes.
That's right. That's right. That's right. That's exactly what it does. It all those tolerances is yeah, you will not, the group are not going to notice any difference. It does it, but you won't see that. So if you look at that, it's 1,663 kilobytes. If I were to turn that off, still works. Look at the size. More than double. 4,000. And yes, when we're going to run it, it's going to be fine. Those steps is not even visible. You cannot even see with your naked eyes. Okay. But it's going to skip those steps by keeping those in tolerances. That's what it is. Okay, so now let's take care of this over here. We have the radius of the cutter, which is 0.1875382. So how are we going to take care of that? If you really want the sharp edges, that's what we did on this part, guys. We just get a flat end mill, and flat end mill is going to cut it with a simple regular cut tool. We can do that also, or we can even, if you want to use ball end mill, you can use a ball end mill. It doesn't matter, use 1/8 ball end mill. If you use radius, you use 4-inch ball end mill, it's going to be 1/8 radius in each. It doesn't matter. It depends. So let's use the smallest end mill. We can use, let's use 4-inch end mill at least. So we have 1/8 end mill to show you. Let's see what is so still we use 60,000 radius anyway. So what is this? The stock model is the top part is gonna change too, because we change the. This is your material, remaining material. So for that tool path, what we're gonna do, we're gonna go finish. We're going to finish, we'll talk pencil tool path later on, it also works. And let's talk about leftover, so you don't see it over here, right click in the white area, go to mill tool path, go to surface finish, leftover. So leftover material, leftover tool path means what is left over from the finished tool path, that's what it is. So I can tell my leftover from the finished tool path is this radius over here, right guys?
Yeah.
Yes. So I'll say leftover. I'll select all the surfaces like we always do. End of selection. You can see 4 surfaces have been selected. Okay. The tool I'm going to use, let's use 1x polymer. On this one we can go about 40 inches, about 7,500 RPM. Surface feet per minute. It's going to cheat everything. Okay, 24,000. That speed limit is okay, speed I'm going to go 75. Surface parameter, FP standard, starting with not everything. Go to incremental, standard, that's good. Finish left over. Maximum step over. Let's go about 6 8 Cutting method is going to be 3D class, that's fine. From slope angle 0 to 90, this is good. This will start from 0 degree, go straight up to 90 degrees. So this angle is going to be less than 90 degrees, that's okay. And the most important thing is leftover parameters. The roughing tool. What was the roughing tool for this last operation? Not that roughing, not that roughing. We are talking about leftover from this time, from the scallop.
The 1/8-inch ball in there?
It was
375 ball.
3/8 ball, right? So you gotta put that roughing tool like 375, and the radius of the roughing total radius is half of that, which is 1875. This tool is right here. 3D high speed scallop. What's that? That was the roughing, that was the leftover from that tool. Not the first rough, not the rough radial, no. The finished 3D high speed scallop was the leftover roughing tool for your leftover. So that's that. So you're going to say the true diameter is 375, it's the ball end mill, and the radius is going to be half of that, which is 0.187. And it will figure out by itself that where was left over. Just ignore these tolerances, fitting tolerances, just ignore that. And you will see that whatever left over is here. So I'll go ahead and change these parameters. So this is 8,000. Let's go about 12,000. Okay. So it will just cut the leftover area over here. The tool I'm gonna use 0.250. Let's see what happens. Okay, let's go ahead and run all of them. We still have a radius over here. We still have 1/8 material, 1/8 radius over here, man. So that's your leftover material. Now, if you really want to sharpen, all you're gonna do, you can just put regular contour tool path, get this here. Just regular. Up in the chin look. Cut to the left, tip 0, 0, 0, make parameters and run parameters from 0. There's a tool path right there. So if I'm gonna run surface finish, we're gonna do another stock model. This stock model we can name stock leftover. And this stock leftover is gonna be from stock finish. And source operation is gonna be leftover. There we go. After this, you can turn that off. You can see the other one. You can turn that on. Turn that off. You can see the other one. Well, that's this. Turn that off. This is your start from. Basically, we start from here. We rough it out. Turn that off. Then we go finish it. Turn that off. Then we do leftover. Now, let me show you, we'll turn this off. Let me show you one more tool path. It's just like a leftover, but this is going to be your finished pencil. Your pencil is just like a pencil that you're carving something at the edge. So here is your pencil tool path. So we're going to leave 0 over here. We're going to select our stock. Our surfaces, all the surfaces. Our surface selected. So, let's use quarter-inch ball angle again. Let's just try to use 1/8 ball angle to see what happens. Cutting style method one way, that's good. Step 4, we can go watch how we do. Style 5 is really good. Maximum go upside 90, you have to screw down a little. It was 27. I'll leave this as is, and I will come back and work on that later on. Let's do that. So this is your pencil tool path, and it works only between those two surfaces. Work as a pencil. It will not work on this. It only works where we have a step between those two surfaces. It's going to create that with a pencil. See the high-speed pencil. Just like a pencil. I'll be thinking about this guy and this guy and pencil tool. That's my pencil tool. Just like a pencil. slowly into the pump. So a little bit at a time. Look at this, how it blends from the top, guys. See that here? See how it's gonna blend with the bottom surface. Watch it. Better than leftover. So you can use one of these two probably, you can use pencil. That's pretty much all about this project, guys.
That's it.
Go ahead and save it, maybe we can post this file